So let's look at some examples of inverses, or starting 6.4 actually, which is on inverses. Okay, so go ahead and you can pause and write down some of this, but I want you to calculate, so maybe just write this down and calculate that product. So you do the product, it's over here, you get 40, 39, and then negative 12 and 12, and then this product, and then that product. You do that calculation and you get the identity matrix 1, 0, 0, 1, which is equal to I. So if you have a matrix that does that, and technically you'd want to go B times A as well, then A and B are called inverses, or we say B equals A inverse or vice versa. So inverses mean you have the product of the two gives you the identity matrix. So it's like a multiplicative inverse for matrices. So for real numbers, you might have like 1/3. If you multiply by 3, you get 1. If you have like negative 2, multiply by negative 1/2, and then you get 1. So it is essentially the multiplicative inverse of matrices is what you're looking for. So this is the identity matrix that we'll be using. So it's 1s along the diagonal and then 0 elsewhere. That's what you get. So, and you can check this too. A times I is equal to I times A, which is the matrix A. So it's the identity, meaning you get it back. The same thing back. So here's a little example to check. 1 times 1, 2 times 0. Then you get 0, 1, gives you the 2. And so if you do this product as well, you get the identity. So you can check that with our 1, 2, 3, 4 matrix. Okay, so then next we want to get into finding matrices. So find the inverse of A if it exists. Okay, so actually kind of the punchline later is not all matrices have inverses. And that's kind of all linked together with solving equations and unique solutions. But we'll get to that later. Find B such that A times B is the identity matrix. So this is what you do. You set up the matrix A like this, and you put it on this side. Then you augment it with the matrix I, like that. And then you row reduce it. You row reduce and you carry the procedure all the way through. And once you get I on one side, then if you can get I on one side, what is on the other side is the inverse matrix, the inverse of that matrix. Now, if you can't get I like this, maybe all one row zeroes out or something, then it's not invertible. Ones I'll ask you, of course, will be invertible, but or there'll be other ways to check later. So let's go ahead and do these operations. We'll call those like row 1 and row 2. So first we'll get a 0 here. It's always your first step. So write 4, 3, 1, 0. And then we'll do this operation. We're going to do negative 13 row 1 plus 4 row 2. That'll give us 0, 1, negative 13, 4. So check that. Okay, and then keep going. Okay, so next we want to get a 0 here. All right, so the next operation will be, we can do negative 3 row 2 plus row 1. And you get 4, 0, 40, negative 12. 0, 1, negative 13, 4. And then the last is to just divide by the 1/4. So we'll come up here. So do 1/4 row 1. And that is your inverse matrix then. So when you do that, you get 1, 0, 10, negative 3, 0, 1, negative 13, 4. Like that. So since you get I, then this is A inverse. So therefore, A inverse is equal to 10, negative 3, negative 13, 4. So what is a way to check to see if that is indeed the inverse matrix? Hopefully you thought about that. Yeah, basically what you can do is you can take this matrix here, multiply by this matrix, and what should you get? You should get I. So you can check if you want. So check and do A times A inverse. And you don't always have to do the other direction, but in both cases, you should get I. All right, so try this one. So this next example, let's see, where's my matrix? There it is. So let's let A equal 9754. And then find A inverse, if it exists. Okay, so carry out that. I'll have it written up for the next video. And I'll probably put on a couple more before we go on to the matrix equation. So that's what I'll put on one more to do. And you can work it out. Actually, how about we do this? Let me go ahead and put it here. And you can do it right now. Here's the other one. So let A equal, and so this is a 3 by 3. This would take some time to do. Negative 2, oops. So negative 2, 5, negative 4, 1, negative 2, 1, 1, negative 5, 9. And do the same technique, but now this is a 3 by 3. If you can do that, you'll be totally fine for the final. I'll clarify some of the details. It's going to be, it'll be more simple for the final. You know, more like a 2 by 2 or part of a 3 by 3, where it's easy to do a calculation. But try this. I'll have it written up for you on the next video, and then we'll go on to matrix equation. It kind of pulls together some of these concepts we've been doing. Okay.